This is lesson 5.2. I can identify zeros of the function by factoring and using the zero product property in Graphing Calculator. So for example 1 here, we're going to practice factoring. This is the same kind of factoring we did in Unit 4. So first look for a common factor. Notice x is a common factor there. Dividing x, we get x squared minus 2x minus 15. This can be factored further. We can factor this middle trinomial. The c value goes on the left. The b value goes on the right. Two numbers that multiply to get negative 15 and add to get negative 2. That works out. So we could rewrite this with the x in front and then the x minus 5, x plus 3 as our second and third factors. Part B, we look again for a common factor. 6 and x are the common factor here. Dividing this by 6x, we get x squared. Dividing 6x by 6x, we get 1. Now this can be factored further. If you recall, this is in the form of a squared minus b squared, which factors into a plus b, a minus b. So we wind up with 6x times x plus 1, x minus 1. So now that we practiced factoring, we can recall how that relates to finding the zeros or solutions or x-intercepts. All of those mean the same thing. So zeros is the same thing as x-intercepts, which is the same thing as solutions. I'm going to rewrite this so it's on one line. Y equals x plus 2, x minus 1, x minus 3. The zero product property helps us find the zeros. So we would replace this y with a 0. And then set each one of these factors equal to 0, recalling that anything times 0 is 0. So x plus 2 equals 0, x minus 1 equals 0, and x minus 3 equals 0. Subtracting 2 from both sides, we get x equals negative 2. Adding 1, we get x equals 1. And adding 3, we get x equals 3. So now we have our three x-intercepts, negative 2, 1, and 3. The next thing we do on this is to look for our lead coefficient. So we notice this would be an x times an x times an x. So our lead coefficient would be, I'm going to write that down, lead coefficient would be x cubed. That's what we want to look at, thinking back to lesson 5.1. Since this is odd and positive, that's going to give us going up on both ends. Right, so we can indicate that this is going to go up on both ends. The next question is the y-intercept. We can actually figure out the y-intercept by multiplying our last terms. 2 times negative 1 times negative 3 is going to give us our c value, or the constant at the very end, which gives us 2 times negative 1 times negative 3 is going to give us a positive 6. So we know our y-intercept is 6. We could then try plugging in a value between each one of these to figure out what happens in between, right? So let's go ahead and try plugging in negative 1 into our function here. So y equals, so negative 1 plus 2 times negative 1 minus 1 times negative 1 minus 3. Or that's going to be, that's a positive 1 times a negative 2 times a negative 4, or positive 8. So at negative 1, we have a point here, negative 8, or positive 8. So somehow this goes down and then comes all the way back up, then goes down. We can try a negative or a positive 1/2. We could try a positive 2 also. Another way to do this would be to use your graphing calculator. Notice my window or my graph goes between -10 and 10. So I'm going to change this window to a -10. Again, that's the window key. This is important. Huge piece to graphing is knowing how to navigate the window. So -10 to 10, and again -10 to 10. I'm going to go by ones. I'm going to graph, and I can actually graph this in factored form. So x, here's our x key, x plus 2, x minus 1, x minus 3. Okay, so you can actually see that this is going to come down and go through the positive 1. It hits a minimum around the positive 2 and then goes back up. So we're just going to come all the way back down here and then come back up. This is still a curve. It looks kind of pointy, but it's still a curve. And there's your graph. A sketch, a rough sketch of your graph. Example 3, writing a polynomial function from its zeros. So this is the reverse. If our zeros are -2, 2, and 3, and we could write one form of this polynomial as x. So we do the opposite, so that'd be plus 2, x minus 2, and x minus 3. Again, those are the opposite of each one of those zeros. The next thing we would do is factor that out. So we'd start by factoring 2, or sorry, foiling, distributing. So x times x is x squared. This is actually of that special form a plus b, a minus b, so we already know that's x squared minus 4. If you forget that, we did that earlier, remember, we went into factored form from the difference of perfect squares. Now we're going to the plus and minus to the difference of perfect squares. So we're going to multiply that times x minus 3. X squared times x is x cubed. X squared times -3 is a minus 3x. -4 times x is a minus 4x. And then a -3 times a -4 is a positive 12. Simplify that. We can combine like terms. We get x to the third minus 7x plus 12. So that is our quartic. Okay, so in order for this to be, so we are a cubic right now. So we would need to add a couple more factors in order to make that a quartic. We could just change the multiplicity of some things and make that work. Let's just change this. Instead of quartic, we'll make that cubic. So now we have a correct solution there. What is a cubic polynomial function? Alright, so this is what happened. This was supposed to be cubic, and this was supposed to be quartic. There we go. Now everything's better. Whew. So here is what is a quartic, and that makes more sense since we have 4 zeros. So again, we can write that out. X minus 2, x minus 2, x plus 2, x plus 3. So actually it's opposite, so these would be the pluses, this would be the minus. So these would both be minuses. So next, we're going to go ahead and distribute. So x plus 2 times x plus 2. Doing 2 at a time works best. We get x squared plus 2x plus 2x plus 4. And then we'll do these two. We get x squared minus 3x minus 2x plus 6. And then combining our like terms, we get x squared minus 5x plus 6. And now, let's see, this simplifies also. We'll multiply this times this. So this is probably our biggest foiling yet. X squared plus 4x plus 4 times x squared minus 5x plus 6. Distribute. So we have x squared times x squared is x to the 4th. X squared times minus 5x is a minus 5x cubed. And then we have a plus 6x squared. Come underneath here. Plus 4x cubed minus 20x plus 24x. And lastly, we'll take this 4 and distribute. So we'll get a plus 4x squared minus 20x, and then finally plus 24. Now we get to combine like terms. This is helpful to actually underline it the number of times representing each degree, so that'll help us arrange our like terms. So you can see here there's only one x to the 4th. We have a minus 5x cubed and a plus 4x cubed, so that's going to be a minus 1x cubed. And then we have our x squared and x squared, so there's 6 and 4 is 10x squared. And then we have our minus 20 plus 24, so that's going to be a positive 4, and then minus 20, so that's going to be a minus 16x, and then plus 24. Quartic, that was our instruction. To the 4th power is a quartic. And there you have it. Question is, what is multiplicity? Multiplicity is actually where we have a repeated root, or 0. So since negative 2 is repeated, you can imagine that's hitting the x-axis at negative 2. It only hits at negative, it can only possibly hit at negative 2 one time. So we call that multiple zeros, or multiplicity. So that's repeated zeros. And what that looks like on the x-axis is it touches. That's where it's, instead of crossing, that'll be a touch. Just like when we have y equals x squared. Y equals x squared. If we set that equal to 0, we would have 0 equals x squared. So that would be a solution of 0 2 times. And you notice it just hits the x-axis there. A relative minimum, so this is indicated down here. Here's our relative minimum. It is a place on the graph that is a minimum value, but it is not the minimum since our graph continues to go down. It is just a relative minimum a minimum for that particular spot. And the same would be true for the relative maximum. Just true for that particular spot. It continues to go up, so the maximum is actually infinity, but for this particular location, this is the maximum value. So the last question asks us to identify relative maximum and minimum. We're actually going to use the graphing calculator. So you can clear your y equals and write in your new function, x cubed plus 3x minus 24x. Graph it. You can kind of see here that there's going to be at least two turning points. You can see that it hits the x-axis 3 times, which is the maximum since our degree is 3. So we mainly just need to see more of our window on the y-axis. So I'm actually going to stretch that to, let's try y minimum of negative 30, y maximum of 30. Sometimes you just have to trial and error, see what works. So I put the scale at 10. Oh, didn't quite get it, but we're getting closer. So let's go back to our window. Let's try 40. Negative 40 and 40. Let's see if we got it. There we go. To find the relative max, we actually can go to this button that says calculate. It's above the trace key, so you press second and calculate. And we have here maximum. We're going to try the maximum first. That's on the left side. Instructions are given to us. It says left bound. That means you want to go just to the left of where you think the maximum value is and press enter. Using your arrow keys, go over a little bit to the right to enter your right bound, somewhat to the right of where you think the maximum will be. And then right in the middle, and press enter again, and it gives you the maximum value. So our maximum for this graph is negative 2.6. So our relative max is 2.65. We're going to round to the nearest hundredth. And the y value is 37.04, 37 and 4/100ths. We'll then find our relative min. Again, going to our calculate key, going to minimum. We're going to go all the way down, pressing your over key. Only the left and right arrows actually allow us to navigate on the graph. We'll go to the left. Now we'll do the right, and somewhere in the middle. And it gives us our minimum. So our relative minimum is 2.65, comma, negative 37.04. So in summary, we talked about writing a polynomial in factored form. This is review. Factoring completely. We then talked about finding the zeros and graphing. The key here is really being able to find these zeros without using your graphing calculator. Also being able to use a simple calculation to figure out your lead coefficient, to find your end behavior, to be able to find your y-intercept, and then from there it's a great idea to use your graphing calculator to help you fill in the gaps. Next we did writing a polynomial function from its zeros. Here we had to change things up. This was a cubic because it ended with a third degree, and we foiled and then we foiled again and got our cubic. just given these 3 zeros. And then we found our quartic, which was quite the process, using our 4 different zeros. Then we talked about multiplicity, which is just indicating when we have a repeated 0. So on your homework, you'll have a question that might say something like, let's do another example here. If f of x equals x minus 1 squared times x minus 4, you have 2 zeros. Our zeros would be 1 and 4, and the multiplicity, so we have a repeat here. We have the x minus 1, the 1 solution occurs twice, so that's where we write our 2. The multiplicity for that 0 is 2, and that's how you would write that. Then we talked about relative minimums and relative maximums, which we used our graphing calculator and our calculate function.